In this section, we're going to take a look at partial fractions. We want to find the partial fraction decomposition of x over the quantity x squared minus 5x plus 6. The first thing we want to do here is we want to go ahead and factor our denominator. So let's go ahead and work with the factored form of it. If we factor this denominator, it's going to factor into x minus 2 and x minus 3. I'm going to keep my numerator of the x. So one of the first things you want to notice is that you have non-repeated factors. When you're looking at this denominator, each of these sets of parentheses is something different. We don't have any of them that are alike in that denominator piece. So when we're talking about decomposing one of these fractions, what we're talking about is we want to break it apart and figure out what fractions were really added together to give us the fraction that we started with. So let's go ahead and take a look at our setup. So here's our starting point for this problem. I'm going to be working with our factored version of the fraction that we started with here. And I'm going to take each factor and I'm going to create a fraction with it in my denominator. So you'll see here is my x minus 2, that's the denominator for my first fraction, and my x minus 3, which I'm going to use as my denominator for my second fraction. And we're going to be taking a look at trying to find these numerator pieces. For right now, I'm going to call them just a and b. We're going to be solving for a and b, and there's a couple different ways we can go about doing this. Let's go ahead and clear out our denominator. So if we want to get rid of our denominators on both sides of this equation, we're going to go ahead and multiply the whole thing by this x minus 2 and the x minus 3. Now I'm going to go ahead and write out my next step the long way, just so you can see what's happening and you can see each of the steps. So kind of think of it as I'm going to take this x minus 2 and x minus 3, and I'm going to distribute this to each piece that I see. I'm going to do both sides of the equation. So here you can see my multiplication step, and what I want to have happen is that I'm going to be able to go ahead and cancel some things. If I take a look at this left-hand side of the equal sign, this x minus 2 and the x minus 3 are going to cancel with my denominator and just leave me an x. And now let's go ahead and take a look at my right-hand side. Over here, my x minus 2 in this denominator is going to cancel with that x minus 2, and I'm going to be left with a times x minus 3. And let's go ahead and do the same thing for our last step. Over here, the x minus 3 on top is going to cancel with the one on the bottom, and I'm going to be left with b times x minus 2. And now we have an equation. Keep in mind we're solving for a and for b in this equation. So there's a couple different approaches you can use so that you can solve for those two letters. I'm going to go ahead and select specific x values, and in doing so we're going to be able to eliminate a portion of our equation. For example, if I let my x value be equal to 3, then this set of parentheses is going to subtract to give me 0, and 0 times a is going to make that whole term disappear, and that's going to give me an equation that I can go ahead and then solve for b. So let's go ahead and pick that x value of 3 and take a look at this next step. So I picked my x value of 3, and I went ahead and copied my same equation here. And then I went ahead and plugged in 3 each time I see the x value. And what's going to happen here is I'm going to end up with 0 times a, and this whole term is going to disappear. So notice this term comes out to give me a 0, and now I have an equation that reads 3 equals And over here, 3 minus 2 is 1. So I have 1 times b, which is the step you see right here. So my b value in this case is going to be 3. Let's go ahead and do the same thing so that we can find our value for a. I'm going to use the same type of strategy. If I want to eliminate this b term, then I'm going to go ahead and pick an x value of 2 so that this set of parentheses becomes a 0. When I let x be equal to 2, notice over here this set of parentheses is going to simplify to a 0, and what I should be left with is then an equation that I can go ahead and solve for a. So when I simplify, I'm going to get 2 equals a times negative 1. That was my 2 minus 3 piece, plus b times 0. The 0 came from doing the 2 minus 2. So 0 times b is just going to give me a 0 right back, so this whole piece is going to disappear. I'll be left with the equation 2 equals negative 1 times a. And my a value in this case is going to be equal to negative 2. So let's go ahead and take a look at what happens when we decompose that fraction. So our a value is negative 2, our b value is 3, and I'm going to go back to one of our earlier steps, and we're going to go ahead and plug in now our values for a and b. And here's our final answer. We have negative 2 over x minus 2 and 3 over x minus 3. So there's our partial fraction decomposition.